All right. Started.
All right. And there we go. People are starting to file in.
Hello, everybody. Ooh, see some familiar names in there.
Yo.
Nathan Graff, what's going on?
I see some Valencia over there.
Yeah, Mr. Valencia. Hello,
hey,
sir.
buddy.
Very cool. We'll give it a minute or two for everybody else to hop on. Oh, hello from India. Very, very, very cool. Happy that you all were able to make it.
Isn't it like the middle of the night in India?
Yeah, I think so, if not close to it.
Yeah.
So we'll give it like 2 more minutes, let people finish filing in, then we'll get started.
All right. 10:30 p.m. Sarfraz, that is past my bedtime. I don't know if I'd be allowed to stay up that late. I'm glad you're excited. Hopefully it'll be a good one. Oh, from Boston, nice. Yeah, hoping it'll be a good one, and we all get something out of it, right?
Tyler, you're blurry.
I know. I'm doing it right now. I don't know what is up with this camera. I wasn't even moving.
I'm telling you, man, it's the lighting, the way it bounces off the back wall over the top.
Yeah, I need to get another little light. Okay.
Okay.
Working in the sock, no sleep schedule. That's right. The alerts don't wait for anybody. Excuse me.
Oh, man. Ooh, might want to do that. So I forgot to prioritize my laptop real quick. Especially with all 3 my heathens home, all streaming and playing games and doing everything else.
All right, Trey. Well, the numbers have started to slow up, so whenever you're ready to kick it off, I think we're ready to go.
Alrighty, let's do the thing. So, hi, hey, hello, everybody. Welcome to Detecting PowerShell Abuse, put on by us here at Scythe. This should be an interesting little workshop. It's going to take a different format than we typically do, where we have you guys like listen to us talk about a bunch of slides, a bunch of concepts, and then play for a while. We're going to be going back and forth between the concepts and time in the lab. Our goal this way is hopefully you get more time overall playing in the lab. What I would recommend, if you haven't already, you should have gotten a link for lab access. Go ahead and open that link up and start it, because it could take a minute or 2 for the instance to spin up.
And that should be sent to whatever email you registered for this webinar with.
It's going to come from events@scythe.io. We can get that started, and then while that's spinning up, we'll go into the intros, talk about the first couple little concepts, what we're doing here today, and then hopefully get some time playing around. So let's move it on forward, Tyler. So who are we? This is me. Hi, I am Trey. I'm our lead AE engineer over here at Scythe.io and the head for Scythe Labs. All of our content you see, all of our threat emulation campaigns, the stuff that we put out, that is me and my crew that you see here on the call. If you want to reach me outside of this call, there's my socials down there. And if you care about my history and what I've done, I've spent 15 plus years or so in IT and cyber between the DoD and private sector. I've done a little bit of ICS, red teaming. I've played the whole threat hunting game, SOC analyst. I've done some consulting. I've spent a good bit of my time in education. I've built content on platforms like Hack the Box Academy and other places. And if you like certs and those kind of things, I've got alphabet soup down there, and there's more on my LinkedIn profile. Let's see, so we got a hand raised over there. Spurious. I think that might be for you, Elaine, someone raising their hand for a link. But Tyler, introduce yourself, good sir.
Yeah, hi everybody. I am Tyler Casey. I have about 10 years of experience doing DCO, which is defensive cyber operations. Currently, I run the blue side or the defensive side of our purple team engagements. Help Trey with a lot of the threat emulations that we put out every week and coming up with detections for those. Before I came to Scythe, I was on a CPT, which is a cyber protection team, where we deployed all over the world for incident response and targeted threat hunting. And then I have my contact info down there if anybody wants to link up. Got my Twitter and my LinkedIn. Twitter is mostly St. Louis sports and St. Louis centric things, but I throw in some InfoSec goodies in there too, some interesting little tips and tricks. So love to connect.
All right, so what are we talking about today? So PowerShell abuse, so what it is, why do we care, and some cool ways that it's done. From there, we'll go into some detection opportunities, like a whole lot of talking about logs and other resources that could be beneficial to you in trying to detect these behaviors and methods that threats tend to use. And then we'll spend some time really thinking about those techniques, actually getting a chance to emulate them, utilizing Scythe and other methods, and experience it firsthand. That's the plan for today over the next few hours. So with that in mind, let's jump right in. So PowerShell abuse. It is dead. Long live PowerShell. So there's a lot that's been going on here lately where people are talking about PowerShell as a useless vector, or it's so locked down and watched that it doesn't matter anymore, X, Y, and Z. And that's really kind of what spurred us into making this workshop. We thought this would be a cool, interesting way to show it off. And this is the root cause of it right here. You see on the slide now, this is why the whole workshop exists. We were watching a couple Twitter threads, we'll politely call them threads, not necessarily fights, where people were just going off about PowerShell and what it is and all kinds of problems and issues with it and it not being a realistic vector anymore. Well, this one here kind of gave a quick little breakdown of not really. It's still here, it's still prevalent, and why change it up if it still works, right? Threats might be doing some different methods of certain tactics or behaviors, but as a primary vector and as something that's already on the host, PowerShell is still alive and well. And that's really kind of what spurred us into making this. And it is an interesting enough topic that we actually kind of rabbit holed for a little bit and started finding a bunch of weird ways that we could start doing things using just PowerShell or using PowerShell as the initial vector to it. And their workshop was born. So why do threats love PowerShell? And I mean, the proof is in the pudding too. When you look at it, if you go check out MITRE ATT&CK right now and just search PowerShell and look at all of the different instances of PowerShell being used somewhere in there, this is just their open recorded stuff that they show. This list is probably another 4 or 5 scrolls long as you're trying to look at it. It's there, it's prevalent. These tools are, like we said, they're native on host. It's a powerful scripting and automation tool that anyone can utilize, whether that's your users, the threat themselves. There's so much built into it that could help with things like basic system administration, task automation, even like configuration and change management, stuff like that. But that also makes it a great initial vector for doing host discovery and enumeration, for hunting and searching for useful files, for doing things like obfuscation of commands, trying to be stealthy, getting remote execution through an environment, all kinds of different ways that they could utilize it. So, I mean, with all of that baked in, and now you're not having to develop and bring new tools and dev new capabilities, why wouldn't you use it, you know?
Yeah, for sure. I think a
So
point too to add to that, Trey, is that on top of utilizing PowerShell, a lot of things that we see all the time in CTI and stuff that we read every day when we develop these threats is that in addition to PowerShell, living off the land is also still widely utilized. You're not going to bring in tools if you don't have to. Being an adversary is one of the times you don't bring a gun to a knife fight. You bring a knife to a knife fight. You bring the smallest, least obvious thing that you can to blend in and hide in the environment. And so we're going to try to show you a lot of those and some detections for those here in a minute. I'm getting a little ahead of myself. I'm a little excited to do this. Some of them are simple, some are more complicated, but we're going to really go through a wide breadth of the different ways to utilize PowerShell natively on the machine, etc.
So Tyler, what detection opportunities exist for PowerShell
Wow,
and
who would have
detecting
thought?
abuse?
You know what? I prepared a little something for this. So we're going to get into what detection opportunities arise in PowerShell, what logs you can use, and what resources you can take advantage of. We're going to talk a little bit about the SIEM, which in this instance is going to be Splunk, which is the best SIEM. So we're going to go in and talk a little bit about that, and then after that, we'll get into the actual lab itself. So where can we see PowerShell activity? You can see it in the security log, PowerShell log, script block logging, and the sysmon log, in addition to any kind of EDR or homegrown logging capabilities that you have in your environment. So security log is native to Windows, it's built in. PowerShell log is native to Windows and built in. The script blocking log is native and is built in, but it's not enabled by default. Not really sure why, especially I guess it's because everybody thinks PowerShell is dead. But the script log logging is not enabled by default. So we'll go into the next slide on how to enable it. We don't use it in our lab because we deploy sysmon, which is the next log that you see there on the screen. So we deploy sysmon, and it's able to catch pretty much everything that we're trying to get it to identify. So it is able to identify script block logging in sysmon. And sysmon is great if you guys aren't familiar with it. It's basically a modular logging solution. So it has a config file that you deploy that will hit on includes and excludes per event types or event codes. It does take a little bit of tuning, a little bit of tailoring, a little bit of work to kind of get it to work exactly how you want. But Swift on security, I think, is probably the de facto starting point for almost everybody. If you go to Swift on security sysmon, you'll find it. I'm sure it's the top link on there. That's a great starting point to go ahead and look on there.
And how much does sysmon cost people, Tyler?
Nothing. Absolutely nothing. It's totally free. It's updated regularly. It's very useful. We like it a lot. It's great in our labs. But if you are not able to deploy sysmon, or you have some other tool or something like that, you go ahead and enable that script block logging. We have some questions over here already. Let's see. Yeah, so yes, sir, you could definitely see that some of the performance may be hindered a little bit by sysmon. It all just depends on what you're ingesting. So if you just deploy it and turn it on and don't do any inclusions or exclusions to it, it's going to blow up your logging. I mean, it is definitely going to be a large resource pull on your environment. So we would recommend starting with the Swift on security, not sponsored, starting with theirs and then kind of tuning it as you go along. Because if you just go in with a blank config file, it's going to be basically useless because there's so much information in there, right?
And to address Jeffrey Rodriguez's question, restricting the use of PowerShell for end users is a very hard topic to breach, because there's always some way to bypass or use something else to open something else, right? I mean, in our experience and stuff, we've seen enabling like constrained language mode and doing stuff like that to at least minimize the vector is probably your best case scenario. But trying to fully say a user can't get to PowerShell, it's in my opinion, it's not truly feasible because it's going to break something else. It's going to inhibit some kind of function, or they can do stuff like call unmanaged PowerShell, calling the actual system management automation DLLs through some
Yeah.
other means, right? So there's always another way.
I'd say too, Trey, you brought up the restrictive mode. I've also seen in some reporting where adversaries will purposely use restricted PowerShell to evade detection because it goes in a different log. It's not logged the same. It does different commands. So that's also, if you do enable that, it's also a vector where an adversary could get in and go undetected. I'd say the only way you could really restrict end users from using PowerShell is to switch over to Linux. They're I don't know if their window really uses PowerShell for everything. It is very difficult to disable it or to restrict it. So we try to hit on ways to just detect the abuses and things like that, which we'll get into here in a second. And then, so to enable the script log logging, here's just a screenshot of it. You just go into the GPO, computer config, admin templates, Windows components, PowerShell, and then you turn it on. Like I said, we don't utilize this in our lab. We just thought that it was important for you guys to see how to turn it on. It's pretty trivial. You just go into the GPO and set it. Sure, you can make a PowerShell one-liner to do it. But yeah, if you can't deploy Sysmon or you want just another free tool that you're able to utilize and have more logs in, I would recommend turning on script log logging. All right, so that takes us into the SIEM. So the SIEM is something that we strongly recommend for all defenders to have and to send all of their pertinent logs to be forwarded and ingested on your SIEM. So you could send network logs, host logs, your security logs, Sysmon logs, everything can be in there. It's all in one spot, and it's much, much easier to hunt across an enterprise environment when all of your logs are centralized and standardized. You can also configure your SIEM to provide automated alerts or perform actions based off of the alerts. So an example of that, if you set up an alert that monitors your milk level in fridge.log, and you have it configured to send you an email of its status, or integrate that alert with a food delivery service and have it deliver your milk without any interaction, you never forget to buy your milk. But
Those Splunk apps are crazy nowadays.
Here in the cyber world, it's more used for your logs, your endpoint logs, your network logs, your proxy logs, things like that. You want it all in one spot. It makes it so much easier. If you're going through an enterprise hunt, you're trying to find the bad guy in your environment as a whole, going machine by machine or even querying like remote event logs is probably not going to do it. It's very difficult. Even if you are trying to hunt across more than 2 machines, you need some kind of centralized location where you can correlate those logs together, have it all in one spot. Excuse me, sorry guys. So yeah, with that, you have the centralized view. Like I said, you have real-time monitoring, so you get those logs as soon as they're forwarded. There might be a little bit of a gap based off of bandwidth and things like that, but shouldn't be more than, I think, probably 2 hours is like the longest I've ever seen it, and that was in a very, very, very slow environment. It allows you to do threat detection, incident response, historical analysis, because the logs are stored for as long as you set them for. By Splunk, I believe it's 5 years by default. You can always change that to be longer. Just more efficient. You can enrich the data with other apps that are built in, so you can plug your CTI feeds into it, and it's also able to scale really well. So most SIEMs do a distributed deployment model where you can have search heads and indexers and deployment servers and things like that. So you can scale across an enterprise. So as your enterprise gets larger or you ingest more logs or something like that, you're able to quickly grow. And we have a screenshot here of a Volt Typhoon threat that we made, I believe last month is when we showed it off in our Threat Thursday. Shameless plug.
Yep.
If you guys go on our site YouTube channel and check out our Threat Thursday, we go over the Volt Typhoon threat and some of the detections on there also. We just wanted to include a screenshot of the dashboard that we made for it to show some of the different things that it's doing over there.
This is something too, I wanted to just touch on it real quick, is we can't stress enough how much having that ability to correlate everything together to search across multiple endpoints at once, or even just having that historical analysis capability is. We've been on several engagements where we've had people that were searching through 7, 8, 9 different tools just to find logs or find potential alerts for one host. Or to where like it'll do an alert, but it only does it locally. It doesn't send it anywhere or tell you anything. And it's just really increasing the time it takes for you to hunt to find things. If you suspect something, it makes it harder to even realize, or even if your tools are working the way they're supposed to, and they give you that alert locally, but there's no one actively watching it, you don't really know. So pushing them to something like a SIEM is going to give you that ability to have it all centralized to see alerts easier, faster, and have more than one person have direct view of the same thing, you know?
Yeah, for sure. Having everybody look in the same spot for the same thing. And then you could always pivot from your SIEM. You have an alert in the SIEM that there is a Mimikatz or something was downloaded onto your system. So you get that alert in the SIEM, you see it, then you could pivot over to Carbon Black or FireEye HX or whatever your endpoint detection is, and then do some further analysis that way. But having it all in one spot is really indispensable. So one of the other topics of the SIEM that we wanted to hit on is keyword detections. So while keyword detections are not necessarily bad, sometimes it's all that you have, right? So maybe you're looking for, I believe in this instance, we have who am I up there. So I just have who am I, no field names, no nothing really specifying anything other than that parent image of PowerShell. But doing keyword detections is not necessarily the best way to go about hunting through an environment. So keyword detections can be easily bypassed by an adversary. There's an untold amount of ways to kind of achieve the same end result. So in this example, we have an adversary trying to ascertain what the user domain and the username is, which typically, like for an admin, you would just run who am I and that would pop up. But let's say you want to be a little more stealthy as an adversary, and you don't want, that who am I is going to pop up. People are going to see it. Looking for discovery commands is not uncommon. So instead of running who am I, which is easily visible in the log just by keyword searching, you echo the environment variables for user domain and username. You can see in that search, we ran both of those and only one of them shows up, right? So it's just an example of how an adversary can go around kind of simpler detections, and how in a lot of the detections that we're going to be going over here in probably about 10 minutes or so is when we'll get to it. They're more focused on state-based, and by state-based we mean like changes to the disk or changes to the state, like user creations or files being created or things like that. So you'll see that some of our detections do rely on keyword searching because maybe it's the best way to do it or just one of the options, but we want to throw this in there to kind of get you thinking in a detection mindset of how can they get around my detection and how can I kind of pivot to always kind of corral them into where I want them to be. Then another shameless plug, we go over this in great detail in our Power to the Purple and detection engineering workshops. We go over kind of how to systematically go through the detection engineering process and kind of resolve this issue as a whole team mindset. Attack, defend, respond. I wore the shirt specifically for this, but I realize I'm standing too close to my camera. And then some key resources you have to make some detections. Sigma is probably the top one that we utilize. You'll see in the lab a lot of our detections come from Sigma rules. Here at Scythe, I make a lot of Sigma rules for our detections for our threats and IOCs that we put out. It is a great open source structured format for writing detections. It's written in YAML. Sigma HQ houses thousands of community detections. They come out with them all the time. It's really great to use if you just go to the Sigma HQ GitHub page. They have all their detections in there. They also host a website called detection.fyi, which is essentially a clone of the Sigma HQ's GitHub. They're linked together, but it's a much more friendly, user-friendly view. It's a lot easier to search and see it. So if GitHub isn't your thing, I recommend checking out detection.fyi. And then the last one that recommend is the Splunk security content. So it is a repository of analytic stories that provide background on TTPs that are mapped to the MITRE framework. They include Splunk searches, machine learning algorithms, SOAR playbooks, if they're available, and they're designed to kind of work together to help in detection, investigation, and the response of threats. I believe too, honorable mention, I believe the Elastic security team also has something that's very similar to this if you're an Elastic shop where you could always translate the rules. All right, so kind of getting into the admin and logistics of this, we'll take this will be our first lab time where we'll hop into VLP, which is our lab platform. Everybody should have had the email, so if you want to hop into that, and we'll do the first couple of sections, which is going to be the familiarization with VLP, to introduce Scythe. We're going to launch our first campaign, and then I believe we're also going to launch our PowerShell abuse campaign, so you can see the steps that are going to be running that, and then we'll have you do your first search in Splunk. So,
Yeah,
Trey,
and this first piece here is just supposed to give you guys a chance to play with the product a bit to make sure you understand how to move around VLP. And once we feel comfortable there, we'll do a quick demo and we'll dive into the actual behaviors and detections.
Yep.
What's up, Tyler?
Nothing. I was gonna say, yeah, if you guys want to go ahead and hop in and knock out that familiarization chapter. Yes, Joshua, this is being recorded. And then Nathan, we see yours in there too. Elaine will handle that for you. So if you guys didn't get a link, or if there's any issues or anything like that, please put it in the chat so we can send you a new link if you didn't get it. And the link should have been sent to your whatever email you utilized to register for this workshop. It's from, would you say, from Scythe events or something like that?
Yeah, events at Scythe.io. I see a link taking care of a few of them right now. Josh, is there a PDF with the lab? No, there is a manual inside the lab, and due to the restrictions in the way that VLP handles it, it is not exportable in any kind of easy manner. But this recording and the slides from it today will be available after the fact. VMware is taking its time.
Yeah. So with that, we'll do about 20 minutes or so to go ahead and go through that. And then Trey and I will kind of go over what was in the lab, make sure we're all on the same page and answer any questions. But we're here for any other questions while you guys are going through the lab, if any issues pop up. And again, if you didn't get the link, it always happens. We have some backups, just let us know.
So here, I can help with this one a bit. We'll make it a little faster. So I'll share this screen here for a minute. While you guys are all getting logged in and getting kind of acquainted with VLP itself, I just wanted to give you guys a quick walkthrough and kind of show you around some of the key points. The first one's being this initial shell. This is going to be the host where we're working from. As you get logged in, it'll take you directly to a Windows login splash page. The credentials for that are just unicorn. And if you ever need to reference those credentials again or anything like that, they're on the first page of the manual, which you can see here on the right side of my screen that I'm sharing. To make that move around and disappear, it's just these carrots that'll make that collapse and expand. From within this view, you can also see the consoles for the other hosts within the environment. We've put them there in the event that you guys might want to play around or need them, but in reality for this workshop, you only need the unicorn host. With the manual, the hamburger drop down right here will help you control table of contents and chapters if you want to jump around and look and see what all is in this. And from there, moving can be from the arrows up here at the top or from the side here. Will help you move around and navigate. Each piece of the manual is going to have little chunks where we talk through what we're doing. And there might be some guided questions, stuff like that. Some of the other key points here, this finish lab button, if you select this, you have two other options, exit or end. Do not click end. If for some reason you have to leave this call early, but you still want to try and practice the lab, your remaining time will pause and save itself if you exit. Clicking exit will make sure the lab stays up for later for you to come back and re-access it. If you click end, it'll tear the whole thing down and you won't be able to get back in. So just be careful with that one. Settings here will mostly control how VLP interacts with your browser. And then the other ones that you really care about over here is going to be the syntax to console. So you can copy or put stuff into here. If you have something open, like let's say Notepad++ on this side, if I hit send, it's going to dump it in there. Copy and paste in VLP tends to be a little finicky. So if you need to move text over, that's probably your best bet. The last few, this one here looks like a keyboard. If you're looking for Control Alt Delete or any of those hotkeys, they're right there. And then you've got console actions. If for some reason the post you're working on kind of freezes up or gets weird, you click that one, it'll take you to the refresh and reset. If you don't like the weird sizing of the windows or the console like mine is currently, the 4 squares there will full screen your window for you so you can have a better view. And it'll auto adjust the resolution and everything for you. Look at that. That should take care of that first page or so of the lab manual. The next couple of pieces will give you guys a few minutes to play. It's going to let you dive into the Scythe platform, get logged in, kind of see where stuff is, and execute a threat for the first time. We'll let y'all play for a few, and then we'll do a demo of that and some of the Splunk stuff and have fun. Let us know if you've got questions or concerns or anything. Is anybody still having issues getting in or hasn't gotten a lab link yet?
Mine is still not loaded all the way. I'm at almost 5 minutes, so we'll see. Normally, if yours go over maybe 5 or 6 minutes, just let us know. We'll shoot you out a new link. Sometimes it can take a while.
Tyler, do you want a new one?
I'll wait. I'll wait a minute. I'm confident that it'll load.
You're confident.
Yeah, foolishly confident.
I don't know. The days went pretty smooth so far. Did you make your sacrifice to the demo gods?
Yeah. I did not. I barely had enough time to leave this room.
Caspia, if you click on the console window itself and then use the keyboard shortcut at the top, are you able to get to that? Or is your browser window just kind of frozen?
Yes, we try refreshing the page.
There, okay. And again, these timers are just kind of relative. If you guys get through the slides faster or through the familiarization piece and you're ready to move on, let us know in chat. We don't want to sit here for 20 minutes wasting time if you guys don't need it, you know?
Yeah, it's really just up there to keep us on track, make sure that we're not cutting anybody short or taking too long. And then should get through to the bottom of page 10. DC is flying through it. Okay, we'll give it a couple minutes because it seems like some more people are still waiting for their labs to load up.
Sparrows, Frozen, like, are you able to interact with the console at all, or even the window at the top, like with the keyboard shortcut and those buttons? If you can't interact with those buttons at all, I would try resetting or refreshing the page. That tends to help too. VLP can be a little temperamental. Yeah, I would try refreshing the page first before resetting the VM. So still loading circular Sparrows. Sorry if I'm butchering your name, by the way.
If you're on a VPN or you're on a work network, it might be interfering with it as well. Um, I can give you another link, Cyrus, if you want to try it out. Oh, okay.
Cool. Is anybody still missing a link or having issues? To get to the other hosts, you'd utilize the credentials on page 1 of the manual, and then you click on the consoles tab button right beside the word manual at the top right. And that'll show you the windows for the other hosts. All right, has everybody had a chance to at least get in and access the lab at this point? All right, cool. So I'll do a quick little run through of what all we're doing here. So from Scythe, we're these next couple pages, probably page 3 to I want to say it's 8, walk us through accessing Scythe, how to build a basic campaign, utilize modules, things like that, and kick off a campaign. We wanted to show this off to you because that's how we're automating this whole piece and utilizing the functions for our hunt today. The campaign that you guys run at the end of those pages will be the one that we're targeting our detections around. So you'll be able to hop into Splunk and look for all of the stuff that happened within that one. I'm gonna take a quick few minutes here. I'll run through Scythe as a campaign, show you the steps, like how to create campaigns, how to execute it, but also talk to some of the key points in the thread there that you guys might see. So to access it from the Unicorn host, if you open the web browser, we went ahead and saved that as a nice little shortcut for you. Click on that, you'll start getting this. So Unicorn, if I could type. Same credentials as logging into the host, it'll be Unicorn. Yes, we know it is a problem. That is all right, because it's just a lab. So from here, it looks pretty bare at the moment. No campaigns have been ran, so there's no real analytics or information to show. But this is the base platform. To move around and get to everything we need would be over here at the hamburger. So from here, we can create campaigns, we can view current campaigns, threat catalog, the virtual file system, all of that fun stuff. If you get a free minute, once you complete the steps, I would say look around, take a look at some of the different threats that we've created. But for now, let's go ahead and work on creating our first campaign. So we'd hit create campaign, brings us up to this window. We're going to call this one Posh because we can. Now we got to pick a target operating system. For the lab, we're working with the Windows environment. So our target OS is Windows. We can choose different modules for communications, whether that be DNS, HTTPS, SMB for like internal relays, or steganography. For the labs, and often the most easiest one to use is that HTTPS relay. And we can apply some customizations to this campaign if we want. Now, what we would be doing down here is controlling how that C2 traffic looks, how it operates, and certain functions or features like safety guardrails. Since we are in an awesome little lab environment, we are not in need of guardrails, but if you wanted to, you could restrict a campaign to only execute if it matches a specific device name or top level domain, things like that, to ensure that your payloads don't just run off or someone inadvertently clicks them from a personal device in a BYOD environment or something like that. But for now, we don't have to worry about that, so we'll leave that as none. This auto pause feature is really good when you're running assessments and things like that with organizations, so you can actually put pauses in between each step. So like it'll run them for you automated. But if you want the steps to not all happen in a certain time period, you want to have control of it, you can turn this on and it allows you to execute only the behavior you want when you want it to. You can set a date range for when the payload's good for, all of the common features you would see in other C2 frameworks, things like that, and a retry failure behavior. We're going to make sure this is set to continue to next step. And we do this because if we set it to any of the others, like retry or mark campaign device status as failure, it may necessarily lead to results you don't want. So like mark campaign as a failure, if any one of the steps in line fails, it'll cancel the whole campaign and the rest of it won't happen. Retry could potentially just sit there and put you in a loop of waiting for something to finish. So we're going to leave it on just continue to next step. So even if it fails, we'll still get a result back and we'll move on to doing other behaviors. The parameters section, this is just specifying where our communications is going, that it's going to be secure comms, and how large we want our packets to be as they traverse. The defaults here are fine, but for me, I'm a little impatient, so I'm going to speed the heartbeat up to every 2 seconds. If you wanted to, like you would see in most traditional C2 frameworks like Cobalt Strike or Empire, things like that, you can control how the headers look for your gets and posts. You can control the heartbeat, jitter, all those common malleable profile settings you would put in place. So now that we've got that, do some signature avoidance. We've got, you can program the database path itself to be something else to kind of help it blend in a bit. Same with the compilation timestamp. This will just make it look like it's been around for a minute and this executable wasn't just generated 5 seconds ago. Now that we've got our kind of configs in place, let's look at actually building out an attack sequence. So from here, we can come in and do this several different ways. We can go the tried and trusted method of manually building our own stuff, or we can come over here and look at several different ways. The first one being the MITRE attack matrix. So usually when the resolution's better, you can see the whole map at once. Right now, VLP doesn't want to give me a better resolution, so we get this block. As we look at these, we can click through here, find, say, a specific tactic behavior we want to do, like let's say discovery. We'll go to local user. That's usually a good one to start off with, right? Who's on the host? Let's enumerate that. So I can select that. I can come over here and hit enumerate all accounts on Windows and hit configure. Gives us a quick explanation. We want to do this. Yes, add the steps. Now we can see I've got 5 or so new steps added to my attack sequence over here. You'll notice too that these steps, as you go through adding them this way, are already tagged via MITRE attack framework. So when it comes to reporting or other things like that, you don't have to take your time to go and match a behavior up to a specific T code. It's already done for you. But that's one way you can go about it. The other way that we'll be utilizing here at the end of this section of the workshop is using the add existing threats. So you can come through here and pick any one of the threats that's already in the catalog. For this one, we'll end up using what's called PowerShell abuse. So I'm not going to show that one up on the screen for you real quick. I'll pick a different one. Let's show Orange Worm. If you hit add steps, now it puts the whole threat campaign that's been pre-built into the sequencer for you. So if we decide we're fine, we like all of these steps, we can go ahead and create our campaign. Or maybe we want to modify a particular step. If we wanted to do that, we can come here, click edit, and change this to whatever we want it to be. So instead of maybe run command C hostname, we can say this is run, who am I? And hit edit. It's that simple. Let's see. So I didn't miss anything in chat. Cool. So that's the other way we can go about it. And then the last route is going to be manually inserting behaviors and steps ourselves. And it's still pretty easy. It's just not as easy as clicking and letting it do it for you. We can come through here. The modules, these all correspond to a specific capability. So like using the run module allows us to issue basic commands like from the perspective of command prompt or PowerShell, things like that. Then the next one would be Upshell. Let's load that one. Upshell gives us the capability to do things through unmanaged PowerShell. So if you've used other C2 frameworks before, you can kind of equate Upshell to how PowerPick works. And then there's plenty of others in here you can utilize if you want to. I'm going to go with these two for now. We'll go to execute an action, custom action. So let's say I want to do something with run. I want it to be in the clear and visible. So I can say, you know, pull the action down there, say IP config, and hit add the action. Now, if I want to do this and I'm not quite sure about how to write out the command for a specific module, if you select it here on the custom action pad, it'll give you some help usage over here on the side. So now I know with Upshell, I could do like -- command and then tell it to do get attack local user and hit add action. So now we can see it place these in here for us. Once we're done, once we have our steps, we can turn around and hit create campaign, or we can save it as a threat for later use. So now if I wanted to rerun this again or use it as a simple test case, something like that, I can come back and rerun the same threat over and over again. So from an assessment perspective, it's really good for that ability to test and retest and validate detections or new security measures put in place. But cool, I've got a sequence now. I've got a couple modules loaded. I've got a couple steps I want to run. So we'll hit create campaign. Once we do that, we can see it popped up down here under the campaign name we set. And it's still in a pending state because we haven't deployed this anywhere yet. To pull the payload now, you've got a couple different options. And in this lab environment, we don't have an agent set up, so you can't push it through an agent. So we have to do this kind of the traditional route here. You can select it, hit this download selector, and it gives you an option of what format you want to deploy it as. For this instance, we'll just say an executable. Then you hit download, and it'll download the client for you. The other option you have is over here at the 3 dots. You can select this and hit direct download links. These will provide you with links that you can go to, and it'll allow you to pull the payload. This is good for other scenarios, or if you want to pass the link somewhere, maybe you're going to put it into a phishing email, something like that, and it'll pull the payload down for you. So now that I have done that, let's go into our downloads. And now this is simplified because we're in a lab environment, so I'm just going to kick this off on the same host here. Hit run. Yes, I know this came from somewhere else. Now it'll run and we'll see a check-in. So boom, there we go. Now we can see as we clicked on the host that just checked in, it's running our steps. So loading our modules. And it'll do this. There we go. So our first run command, we can see it succeeded. It tells us the timestamp, how long it took to come in. We can see the request of what happened, and we can see the response of what we get back. So like you would see anywhere else. So let's see what our upshell one said. Select command get local user. Now we can see I used command prompt basic syntax, and I also used PowerShell syntax. It understands both. So that is the basics of running payloads or implants within a campaign. You have one other cool option here, the shell. If you wanted to do something live instead of through the automated fashion, you can do so as well here. So now I know my module is loaded or run an up shell. So let's go run. Who am I? So I just issued a command out to the implant, and it kicks back with my result of Unicorn Labs. Unicorn, that's who I am on this host. And I can see that it now tagged that behavior in our running list of other tasks that have happened as well. So you don't lose anything you do in the shell. It's an interesting way to run commands, or if you need to fix or do something different. But in a nutshell, that is accessing Scythe and running campaigns. I would urge you guys to take a second and check out the threat manager. In here, you can see the catalog of a bunch of different threats we have loaded into the lab environment for you guys to play with. You're not, by no means are you stuck to just use the one that we tell you to exactly in the guide. If you want to experiment, play around, this is your time. Take a chance, run some of these other campaigns and see how they work out. If you wanted to take a quick look at the one we're going to use for the lab environment, it's called PowerShell_abuse. You can select that and see the attack sequence that's going to be executed today beforehand. But we've got notes within there telling you what they are, what's happening, and then the actual commands themselves. So go ahead, take a few more minutes and check these out if you guys haven't gotten this far yet. And then we'll let Tyler kick off talking about some Splunk stuff here in a couple. As always, if you've got questions or concerns, throw them in chat and we'll address them.
Yeah, there are a few issues in the chats. We're working through those now, and then I'll get into the Splunk part here in just a few minutes. All right, Donna, I have taken you off mute, I think.
And I'll try to be quick, okay? So, if I go back into the lab, there's a lot of verbiage, right? And finally I got to the part where I don't understand what the components are, right? So I'm in Scythe, right? And I get that we're gonna create a campaign and, PowerShell abuse, and you just ran through more of it. But what of all these, the VMs and clients, and what's really being fired up?
So for this portion
Like, can you bring up the
lab,
document that we just first went into before we, when we had to click on the link? you know, the site.io instructions. Yeah, okay. So
Yep, it
can you
should
make
take you
that
to this
in
here.
legally blind here amongst my other challenges?
Let's see.
Okay, cool.
See if it lets me pop it out and still show it.
That's better. That's cool. Cause like once you get in there, then I'm like kind of trying to toggle back and get to this text. So I
So-
got beyond the like, you know, changing your password. So it's fired up.
Okay, so the text was hidden on you. If these carrots here should make it reappear where it says collapse expand panel.
Yep. Okay.
And then this first page here is just
Yeah.
walking you through the information, what hosts are and the credentials to access them. For the lab, you don't really need to go anywhere else as long as you're in the initial unicorn and you're on this web page. As you can see with mine for Scythe, you're good. There's
Yeah,
no other
okay.
host you need to access.
All right, because I saw all those IPs and I wasn't sure what, you know, okay, so you fired it up for us. Okay.
Yep, these are there just in case, and it's our default page for all of our workshops. Some of them use multiple hosts, some of them only use the one. So like in this instance, we're just using this host. You don't need to move around or anything.
Okay, all right, thanks.
DC is all set now.
Okay,
Cool.
awesome. We'll
Tyler,
give
you
it,
want to hop into some Splunk stuff here in a minute?
yes. Trey, do you want to answer Spiros's question while I get it loaded up?
Yeah, so how you compile the threat emulation scenarios and email the info about deployment execution. So Spiros, are you asking how did we come about finding the information for the campaign you see in Scythe or for the one for this lab? I guess I could talk to that one kind of generically, huh? Overall, for the campaigns in general that you can see in the environment, those were made by multiple people on our team, and they came from open and closed source intelligence. So really anything that we could find talking about those specific threats or maybe that campaign that it's geared towards, we dug through all of that open and closed source CTI. We found actionable behaviors and things within them that we could utilize to make an actual step and scenario. So it's not stuff we just kind of came up with willy-nilly and decided this would be cool and named it something fancy. We're actually going by stuff we're seeing these threats or these specific campaigns doing in the real world. So that's where a lot of that information came from. From there, we pulled it out. We put the behaviors into a kind of a flow chart as our process, and then built them out here in Scythe. And that makes them exportable and usable for all of our customers as well.
Yeah, in the same vein as that, this is a little bit different than what we were talking about, but I'll put, we utilize this start.me page that I just put in the chat for everybody for a lot of our CTI. It's kind of like the starting point. So if you're looking to like build your own threats or find some CTI that's really usable, that start.me page by Cyber Ninja has a ton of resources on there. Okay, and then, excuse me, Scott had a question for where do you click done? It should just be once you download the client, that should be it. It should just pop up over here. The click done on there might have just been from a previous course or something, or a UI update.
Yeah, we can remove that line.
Yeah. Okay, so
That's our bad.
yeah, thanks, Scott. Yeah, if you see anything, anything in there, or just throw it in the chat, and we'll try to address it. So Elaine put in there that if you see the AnyDesk pop up, you might see AnyDesk pop up. You might see like a PowerShell window pop up here in a second. That's because we should have deployed the PowerShell abuse threat, and it downloads some of those things and launches some of those things. So any pop-ups, I think calc pops up also. So anything in that, it's because it's built into the threat. So we should have all deployed the the threat, I'm not going to go all the way through it because that's what the whole workshop is. So I go through it now. We give everybody a few hours back. But you might notice that in the first three, we have these variables that we have set for remote computer name, remote user, and remote password. We have those set in there because we utilize this threat in maybe in some PTEs, which are purple team engagements, or some other threats. So you can set these variables to for like lateral movement and things like that. For this workshop, it's not necessary because we're just deploying everything on this unicorn host. But I just want you to know that's why those are in there. You could set them to whatever remote machine you have if you're deploying this in your own lab or on an engagement or something, and then it would take the results of these variables and plug those into the steps later on. Just wanted to throw that out there. All right, so let's get into Splunk. Let me move my manual over, make sure that I'm following the manual. So should just gone into a little bit of what Splunk is, you know, some more information about the SIEM and things like that. But so the point of this one is to kind of do our first hunt, and make sure everybody is familiar with Splunk and is able to kind of navigate through it. So the first part should take you when you get in there to this screen. It's going to go over to search and reporting over here on the left. It'll take you into the search app. Very important. Please set your time. This will drop down to all time. If anybody is familiar with SIEMs, they know that sometimes when you set them up in lab environments that do not have constant access to the internet, there will be a time skew. So Splunk thinks that it is 4 hours in the future, which we'll see here in a second when we start doing our searches. So just set it to all time, and that way it'll show up. If you have it for just the default past 24 hours, you're not going to see the logs until 4 hours from now because it thinks, like I said, it thinks that it's in the future. So you can go in here. I'm just going to type it. You should be able to copy and paste it the way that Trey said. If you don't want to type it out, just be able to highlight that and then not that way with clicking the send text to console and then send it in there. Make sure that you're clicked on the search bar and it'll send it through if you don't want to type it out. So in there, we have it set to all time. We're going to be looking in the index of main, so where we have everything set to. Again, it's a lab thing. In the real world, you probably don't want all your logs going into one index. You would want them spread across however you have it organized. And then our source here is the sysmon log, which is what we'll be using for a majority of our detections. We're looking for the image of system info and the parent image of run DLL 32. So this should hit on that initial campaign, that first campaign we had you make, where it just ran system info, and then you sorry about that, trying to fix my camera. There we go. Where you ran system info, renamed it, and then launched it utilizing run 32 DLL. So you can see here that it pops up. I don't really like this view. I prefer to table out the fields that you want to see, or do some stats commands on fields that you'll see, which we'll get into in the detections here in a little bit. But you can go in and just table, I call it the data flow or flow data, if you get that. So we look for time, computer name, parent image. I typed it before to make sure that it would work. So you go ahead and you can type out all of the fields that you want to see, and then it's just a much cleaner view. We only have the one event, so it's not super cumbersome. But if you were actually doing this across an enterprise and you had hundreds of events or thousands of events, you would want to group it or visualize it in a better way. You have that, and then we just put some kind of
Tyler.
What's up?
If they click that bookmark to get to Splunk, that should take them right in, right? They don't need to log in.
They should have to log in, but I can log out. Once you click on it, the unicorn info should be saved, but it should be unicorn. Does somebody have an issue logging in?
Yeah, we have one and the same unicorn's not working. So we might have to reset them.
Okay. Yeah, I'll look at that.
Just wanted to
here in
validate.
a second, but yeah, it should just be unicorn, and those credentials should be saved. Everybody's lab environment should be exactly the same. It all deploys from a template. So we'll check that out here here in a minute. Then we included some guided questions down there at the bottom, just because we're not familiar with everybody's experience in the SIEM or doing detections or anything like that. So in this section, we dove into Splunk, executed a query. What index did it come from? We see it came from indexes main. And then what's the computer name that it originated from? We can see down here in the computer name field, the unicorn.unicornlabs.local. We have that. One other, so that is kind of our intro into Splunk. I wanted to jump ahead just 1 second while we're already in the lab manual. So under the, once you click a few times, get into slide 14, you'll see this obfuscated and encoded command. So for the rest of the workshop, it's going to kind of go in this format where we'll talk about the different behaviors or abuses of PowerShell that are happening, a little description of what it's doing. This is the actual commands that are being run from the threat. So you can see that it's being run right there. We pulled them out so you can have them for reference and not have to kind of go back and forth between multiple tabs. And then we get into the detections right underneath it. So a lot of these detections, like I had said before, are from Sigma rules that either we created or got from the Sigma HQ. Most, or if not all of them, are downloaded and stored on your desktop in the Posh Abuse Sigma. So you can go in there and right click on them and open them in Notepad++. And you're able to go in and see the Sigma rules. These are just the detection rules. We're not going to get into how to read them or anything like that. We have another course for that, or you could hit me up and we could talk about it as long as you want. But in there, just wanted to show real quick, if you are familiar with Sigma or you want to translate some of these rules on your own, you can go in and copy that rule and then go over to uncoder.io. We don't have a tab for that, but it's uncoder.io. sigconverter.io will also work, but I prefer this one. And then from here, you can go in and just paste that Sigma rule in there. In this drop down, go down to Splunk, and then you can click translate, and it will translate your rule from the Sigma format into the Splunk query language, SPL, the Splunk processing language. And then from there, you can copy and paste it into your SIEM and search on it that way. It's a pretty standard format, or it is a standard format for people to go through and find rules. So as you go in, we are not limited in our detections that we can run today or that we can try out today, right? So as we're going through, if you think of a detection or you're on Sigma HQ or detect.fyi or the other resources that we pointed out, if you see some Sigma rules and you want to go in there and translate them and plug them in, please do. Please let us know. There are so many ways, just like adversaries have so many ways that they can kind of do things differently. There are a ton of ways to search for different anomalous or malicious behavior. So we did not cover them all in this course, right? So I just wanted to throw that out there while we were kind of in the lab before we get into it, because I know some people are going to go ahead. People have things to do. So yeah, just wanted to throw that out there. Okay, was everybody able to get through this part with minimal issues once we were kind of going through it?
Priscilla's still locked out of Splunk, not sure why. So
that is very odd. Let me.
It said too many attempts, but I don't know how to.
Okay, give me 1 sec. I will send her the admin username and password and see if that works.
All right, no worries, Scott. We can give it a few more minutes to give you time to finish going through the campaign inside. And now you'll have plenty of opportunities in the other labs too to get your Splunk on. So
yes. Let me go ahead and share this screen real fast.
Todd, for Sigma workshops, we do not have one directly scheduled, but if that is something you guys are looking for, we can add it to the list of our upcoming workshops.
Yeah, it was one that we did
Someone's
a
asking
couple
for
months
Sigma.
ago. Yeah, one we did a few months ago. I'm really interested in it. I think it's such a great way to share your detection rules with the whole community. It's a standard format. I could talk. I mean, we have a whole thing about it. I could talk on and on about it. But yeah, if that's something people are interested in, we'd love to do it again. We have it already built up, so it'd be easy get that sucker going again. Just give me 2 seconds. I'm going to send Priscilla the password and see if that gets it going. Sorry about that. Okay. Priscilla, I sent you, so it should be admin, and then that password that I sent you. So if you go ahead and try that one, you'll have admin permissions into our instance. So if you break anything, now it's on you. Hands off. All right, we'll give it just a minute or two, make sure everybody is good, and then we'll go ahead and push on. And then now we'll get into the actual different abuse techniques and making sure our camera is not blurry. Having more, I'm like Trey with the mute button. It is getting me left and right. But we'll go through some of the abuse techniques and the detections for that. It'll be a lot more lab time. We're not going to talk for too long. So, Trey, I think with that, I think you can go ahead and hit this one.
Is it admin or administrator? Because that did not work.
It should be admin.
It just says login failed. So I'll give her a new link and
Okay.
I'll give Priscilla a new link and then so we'll have to create some threads again.
Okay. Yeah, very odd. Sorry about that. I'm not sure what the issue could be. It's always something.
Yep. VLP likes to VLP.
Yeah, it's always something. Okay. Yeah, we'll get it going, and then Priscilla, if there's we'll send you that new link, and then if that doesn't work, let us know and we'll figure out something.
All right. So let's move it on forward. Tyler, you got control, bud.
Sorry.
Okay, so first technique we're going to talk about, this one's super simple, super easy. I'm sure you guys have seen this before, but it has to be mentioned because it still works, and we've seen people miss this all the time. Obfuscated commands. So we're basically just trying to attempt to obfuscate or hide the commands we're issuing or the patterns within files, things like that, just to make it more difficult to analyze and find when we're doing our hunts or our search or to signature on these behaviors. What we're showing here in this example is basically just taking the built-in encoded command capability from PowerShell, which base64 encodes the data, and executing it that way. So what we can see here is the request happens. We did PowerShell exe-e, the encoded string, and it ran the string. So in this instance, it is running who am I? Super simple, but it's still a very good, a very favorable way to show this. This kind of abuse is really common. It's really easy to do. Through looking through a lot of CTI, this one really kind of irked me a bit because I didn't want to just show you guys base 64. But it seems like almost every piece of CTI, every resource I looked at that was talking about obfuscated commands or things like that when using PowerShell is only base 64. So I tried to look into why is that? And it turns out it's the only one that there's really a native commandlet for. PowerShell can encode things into a bunch of different formats and character types, but the only one that it was able to natively issue commands in is base 64. So that's what we really have, and that's what we have access to. And as it turns out, that's what almost every threat that I could find that's doing anything like this was using. They're not using some kind of special cipher. They're not using any kind of crazy encoding. They're just throw it in base 64. So with that in mind, Tyler, let's talk about the detection methods for it.
Yeah, so we have one of our, so like I was kind of showing in our going through the manual, we have multiple detections for each of these, or multiple for most of them, for each of these in the manual. For the sake of just talking about it, we're just really going to be covering one. Before that, Jeffrey asked, would these abused powerful PowerShell techniques be detected by application whitelisting or EDR tools? So the CTI that we had referenced for the commands in this threat and in this workshop were observed in the wild, unobscured on endpoints across all kinds of different industries. So while some of them may be caught by EDR or application whitelisting or something like that, all of these were run within the last 2 years on a machine, undetected or unalerted, unblocked. So it is very realistic that even though these commands might seem kind of simple for some of them, we'll get into some more complicated ones later on. All of these execute in the wild, even on some of the PTEs that we run. When they don't put any exclusions in or don't put any application whitelisting or anything like that, we have threats that run PowerShell and do whatever in clear text that go through all the time. So it is not caught as often as you think it might be. Yeah, so for this detection, we were talking about the obfuscated commands. So specifically the encoded PowerShell. So we see that it is in the sysmon log. It has an image of PowerShell, and then we just kind of have some command line arguments in there for what you would typically see as command line arguments for encoded PowerShell. So that TAC E, that TAC EN, ENC, kind of a bit of the keyword detections I was saying you could kind of get around, but it's still a valid detection. So you can see in the output that PowerShell was running the encoded command of DWB ... So you can go in once you detect it, you can go in and unencode or decode that bit in there and see what the adversary was running. Encoded PowerShell commands are not super common. You might see some maintenance scripts or administrative scripts running these. Sorry about that, I'm a little caught up. Might see some scripts that run these, but for the most part, if you see any kind of encoded commands, you would think that someone's trying to hide something, someone's trying to do something without being seen. And in this case, they are going in, and this is going to run Who Am I, which we're going to see here in the lab here in a minute, but just a kind of basic detection to go in and alert on encoded PowerShell. Which takes us into the next one, Trey.
So unmanaged PowerShell, if this is a new concept to you, you're in for a treat. This was one of those things that kind of blew my mind when I first heard about it. It's been around for a while already, and you have some form of this and the capability of utilizing it through all the normal C2 frameworks you can think of nowadays. But really all unmanaged PowerShell is taking advantage of DLLs and things on the host. PowerShell.exe, the whole little terminal, the thing that pops up, is really just a vehicle that allows you, the user, to access a lot of these .NET code types, and we're doing all of this through system management automation DLL. That's what's really doing all the work behind the scenes. So this tactic, what they found was people were saying, well, if PowerShell is getting locked down, if they're putting all this logging and monitoring on PowerShell, watching for its execution, all this and that, well, why don't I just bypass that and go to the DLL that has access to everything already? So that's what we're doing. And in the lab, we do this through the upshell module that you guys saw me demo earlier. Some of the steps that are happening within the threat you ran will utilize that. And the interesting part about this is actually being able to view and see events, behaviors, commands that were typed or issued through unmanaged PowerShell is extremely difficult. And it's really not easy to see. So this is where we were stressing earlier on the whole concept and thought of think about state, think about changes to the host instead of trying to keyword search for threat hunting or catch specific commands and alert on commands. Think about, well, can I determine if changes have been made to any of my critical groups, any of my critical files or assets? Have the permissions changed? Stuff like that. Do you have any users that were added to those key groups? So like maybe Jim Bob was a part of normal users yesterday, and today he's got a new group permission set applied, or maybe the domain admins group went up by one. Now all of a sudden there's been a state change. Only so many people can do that. If it didn't happen from one of your techs or administrators or whoever might have that capability, now you know there's an issue, right? So paying attention to state as opposed to just command hunting is going to be the best route when it comes to looking at unmanaged PowerShell.
Yeah, for sure. I mean, great hit on that. The last slide for the detection method, we had a picture of our Splunk query in here, and here we have John Cena because you can't see him, right? It could be a lot more difficult to detect. Off the shelf, most tools are not going to be able to have or will not have visibility over the command line arguments that are ran with unmanaged PowerShell. It's going to require some additional tuning, some DLL tuning, DLL hooking, things like that, or a more advanced, aka expensive EDR solution that kind of comes with that functionality or has that functionality that you can turn on. So that's okay. So we just have to kind of think a little differently about how we would detect this as opposed to looking for command line arguments, right? So if we take a step back from the commands that an adversary is running and instead focus on the end state or what their actions on objective would be, we can craft a detection with a little more fidelity. It's just a little different. So Trey had kind of hit on that you want to focus on those state-based changes, and that's exactly what we want to do. So an example of this is if a user is created via unmanaged PowerShell, you're probably not going to see the command of new local user or net user or whatever they're running to achieve this. But what you will see, what they can't hide, what you can't make go away, is that actual user being created in Active Directory or in local users and groups. So for this, instead of thinking of having a detection for command line in new TAC local user or net or whatever, like I had said, you want to focus your detection on monitoring for state changes. So for the new local user, you would monitor for a new user being created, for the group change that Trey had alluded to, or a file being downloaded, a file performing, like a file reaching out to the internet, doing DNS queries, things like that. So while you can hide the command line arguments and things like that, you cannot hide what is written to disk, and you cannot hide what's logged by other tools, right? Does that make sense? We have a bunch of examples of this with, I think in the lab, we do a service creation. So it's like those exist somewhere. You just have to look in a little different of a spot to try to find it, right?
So WMI is this is another one of those it's really common. We've seen it in use for years, and it's not going away anytime soon. They'll often exploit WMI. They'll use this in combination with PowerShell and other tools or functionalities to do all kinds of different behaviors, from information gathering to maintaining persistence through things like event subscriptions, to execute process on remote hosts. Maybe they're trying to do remote information gathering, anything and everything they could do from WMI. And this is when we've got a couple that are set up in the threat. You'll get to see this kick off. You can do some of the keyword searching like we were talking about here, and I'm sure Tyler's going to show off some more here in a second.
Yeah, so for WMI, for this detection method, again, we're going to be looking in the sysmon log where the image is PowerShell, and then we're going to be looking again at those kind of command line arguments, which are typical WMI execution methods. So this is not an exhaustive list of every way that you can utilize WMI. We just kind of started it, and you can always add more to it to broaden your detections. You can also see that we're viewing the parent image and the values of the command line. So with that, we can see that C users administrator desktop PowerShell abuse.exe, which is what I named the threat campaign when I downloaded it, is the parent image or the parent process of the WMI execution. So even if WMI execution is common in your environment, and this goes for everything, not just for WMI execution, but if WMI execution is very common in your environment, you could exclude the known good parent images from your search with that parent image does not equal whatever your image name is. Similar to how we did it where we excluded the parent image of qqq.exe. That was a different threat that we were working on from the search. So I like to list out the parent image because I think it's very telling of malicious or at least anomalous activity. So this executable is launched from the desktop folder. That's pretty odd, right? Most of your executables should be coming from either program files or system32. Depending on how locked down your environment is. In your home network, it might be a little different, but in an enterprise managed environment where you work, a place of business, it should be pretty locked down, where you really shouldn't be seeing things execute at a temp, shouldn't be seeing things execute from downloads or desktops or app data, places like that where adversaries like to hide. So by listing out the parent image, you could go in and exclude, like, if the parent image is not in program files or system32, to then alert on that, and you get a little more fidelity. You don't get as much noise. This is a lab environment, so we were not going to have a ton of noise, right? But imagine if you're hunting across an enterprise, you're hunting on somewhere with thousands of users, thousands of endpoints all over the world. It's going to be a lot more noise. So by utilizing that parent image and kind of filtering out what is good, or what at least your risk appetite tells you is good, you should be able to have a little more fidelity in your search and not have so many false positives.
All right, last one, then we'll get back to some lab time for a bit. Just so you guys are aware, if we didn't state it beforehand at the beginning of the lab, with these different behaviors, we're going to run through 3 or 4, discuss them real fast, and then you're going to have an opportunity to hop back in the lab for a while and practice hunting and searching for these 3 or 4 different methods. Then we'll come back in, we'll talk about 3 or 4 more, and let you guys go back to hunting. So we're getting it in smaller chunks instead of us just running our mouth for 2 hours straight. So with this one, ingress tool transfer. It is very trivial to utilize PowerShell to pull in files and payloads, tools, anything you can think of, and move them around even internally in an environment. I mean, we can do this through, everyone's seen invoke web requests before. You still got wget, curl, all these different things that are built in on hosts. And it's even easier and gets more interesting too when you start thinking about things like Windows subsystem for Linux being in place in certain environments or on hosts. Now you can utilize bash to do these kind of things for you too. But like bits transfer internally, you can use things like SMB or NFS to move tools internally. Maybe you've got other protocols that are in place that you can use as well. We've seen FTP live before, been able to use that. Using things like PSExec or WinRM can help out with some of this as well. It's really just a matter of what are you trying to do and where are you trying to get it from. On the slide, we include an example, as this is a simple one. It's not encoded. There's nothing happening. We're just going and requesting PSExec from sysinternals live, and we're outfiling it to an option or an object on disk. You could see these things combined with some of the other methods we've talked about before, like utilizing unmanaged PowerShell or obfuscating commands. And this is really what we want to drive home and where we're getting to is all these individually might seem simple, but as they start getting combined by these threats, it starts getting harder and harder to hunt for things. So that's really the simplest way to explain ingress tool transfer, what we have going on here. And you'll see something very similar to what we have in the example in the lab. Tyler, let's talk about detections for it.
Yeah, and then too, because you hit on it on things getting a little more complicated, a little at the end of the workshop, at the end of the threats, we have ones that are more complicated that combine multiple different abuse methods that we're talking about. So I know that these one-liners, they seem a little simple. They're like that by design. So we have ones that combine unmanaged PowerShell with ingress tool transfer and things like that, to make it a little more realistic at the end. So you can think of these as kind of like a building block to get to that point. Yeah, so for this detection method, probably the simplest way to do it would be just looking for that invoke web request or IWR or wget or curl or things like that, some common command line arguments. But one that I find particularly useful is the mark of the web, which is what we're looking for here. So if you've never heard of it, the mark of the web is an alternate data stream of the zone.identifier, which is added to files downloaded from the internet. And inside of that ADS, alternate data stream, it'll say zone ID 3, which 3 means the internet. And then in the content of that, we'll actually have the referrer URL and the host URL of where it was downloaded from. So in this, we're going to start pretty broad in the detection that we have here. And essentially, we're just looking for all files that have the mark of the web, and viewing the target file name and the contents of the alternate data stream. So we see that the top one here is 7-zip that was downloaded from 7zip.org and had some GitHub user content in there, which is kind of interesting. And then we see that the service logon, the second one, was downloaded from asterisk unicorncroft.com, which is one of our Scythe instances. So based off of your environment, you may need to do a lot more tuning and exclusions, but it's really valuable to know what files were downloaded from the internet and where they came from. I find this particularly more useful kind of if you're going backwards. So if you think of the MITRE attack framework as like, this is what an adversary can do. If you know that there is an impact like ransomware and you're working your way backwards to find out what was downloaded initially and executed on, this is where I find it particularly useful. So if your hypothesis for this intrusion that you're responding to is that there was a drive-by download or something like that, something that was downloaded from a website, you could go back with some of that knowledge you have of like, oh, we're seeing a lot of communication to this kind of novel domain name or IP address or something like that, or oh, we're seeing some DNS requests coming from this image to this website. You could essentially just look for that website in the content of the alternate data stream, and then find out what file was downloaded from that website. So I think that the mark of the web, this is kind of a new one to me, not the concept of the mark of the web, but the actual detection for finding it, I think it holds a lot more fidelity than just looking for like curl or wget or IWR, invoke web requests, things like that.
So this is actually, Tyler, a really great example of why keyword searching here can fail you.
Sure.
A lot of people understand how you can download things through PowerShell using like invoke web request or IWR. I actually snuck another one into the slide on the red teamy side for you on slide 23. So the invoke REST method. A lot of people don't know that that's a thing, but it is basically a wrapper around invoke web request. It can do everything IWR does, but more. So if you were just trying to keyword search on like invoke web request or IWR or any combination of those, a download or a pull-in from somewhere else wouldn't have flagged for you. But on something like this with the mark of the web, that would have still identified it regardless of what commandlet or tool I used for the download. So I was trying to be sneaky there, and you actually still caught it with your base detection. So that was actually
there we go.
Cool.
Well, and then too, we're talking about other ways to do things. If you even just take that encoded command that we were talking about in the beginning, you encode an IWR invoke web request commandlet in there, it would be bypassed by just the keyword searching. So I find this very, very useful. I think it's really neat and really cool. One thing to be a little cognizant about is so a lot of the threats that we download through PowerShell command line just because it's easier. It will not display the target file name for what if like you rename it. So like normally when we do it, we'll do like out file and give it a different name, so it's not just the service logon 1005, because that's what our default threats are called. So in that, you need to be cognizant. That's why I like to look for the what URL or domain or refer that it's reaching out to, because the name is what it is, like what it's stored as, if that makes sense. No, that was kind of a strange way to say it, but
Well, with that, there's also a couple other caveats here, right? So the mark of the web is a really cool, interesting search way, but like all other searches, it's not infallible. There's several different ways you can bring files in, especially on Windows, like putting them into an archive, things like that, that will bypass and not apply this mark of the web. So if stuff gets pulled in that way, you do have the potential of still missing it. And I just want to drive that point home that nothing is infallible when it comes to doing threat hunting and these kind of detections, as well as being the threat. There's always another way, right?
Yeah, for sure. Yeah, if there was only so many ways to do it, we would have solved this problem and we wouldn't be doing this talk, right?
Yep.
So with that takes us into our lab time. It's like Trey was saying, we're gonna do about 4 or so and then go into the lab so we get some time to hunt. You guys don't just have to hear us drone on. So we're gonna go ahead and go in there. We're gonna do the execute PowerShell commands, which is that encoded, the tooling, evade detection, WMI, things like that. It should be, oh, my thing went away. Trey, do you have what what manual number it'll take them to?
Yeah, mine's just coming up right now too.
All right. Sorry about that, guys. If you don't stay on it long enough, it'll send you back to the screen. You have to go back in and relaunch it.
So that should take us through.
I think
It
to
looks like
18, right?
Yep. Yeah. Page 18 in the manual,
Okay.
I think.
Yeah, so you guys want to go ahead and hop in the manual on the lab. We're going to be working to page 18 in with the manual. Like I said, we have the Sigma rules there if you want to look at them and convert them. If not, I already did that for you. Underneath it, it has the search. Go ahead and throw that into Splunk. Please make sure it's set to all time. And we, like I said, we have some different ones in here. We explain a little bit of what they're doing, and why we would use that search. If you have any other ones that you use or any other ideas, you can go ahead and throw them in Splunk, see what you come up with. If some don't work, let us know and we can talk through that. We say, Trey, 20 minutes.
Yeah, that should be fine. We'll
Okay.
gauge it probably around the 15-minute mark and then demo while people are playing.
Okay, yeah, so we'll give you guys about 15 minutes and see how everyone's doing. The same as with the other one. If you get done super early or having issues, please let us know. We're not going anywhere. We're right here. So see you guys here in a little bit.
How's everybody doing so far? Anybody running into any pitfalls, issues?
Nothing heard on that. Give it a couple more minutes, and then I won't go over all of them unless people. Oh, we couldn't get back into the VM. Say, yeah, Donna. Sometimes it will. I just lost my train of thought. Sorry. Sometimes after a little bit, it'll time out, but you should get redirected to a screen that has all of your enrollments on there. If you see one that says PTW-POSH, POSH, you should be able to click on the enroll button on there, or enrolled, one of those two, and then it should relaunch it.
Or if not, you can just close the tab and click the link again.
Yeah.
Cool. Well, you want to start showing them some detection fun here, Tyler?
Yeah. I won't go over all of them, but there's two that I think are really neat. So let me share my screen. And then obviously we go over whatever anybody wants to talk about if they have one in particular. Hey, I get so discombobulated when I go to share the screen and everything changes. And like, where's all my stuff that I just had up? All right. So in Splunk, which one is this? This should be the unmanaged PowerShell. So I was saying in here, so we show in the first one of these, the just echoing the user domain and username. I do not know of a good way to detect that. So if somebody has any ideas on that, I would be genuinely curious to know. But you can also think, you're not going to be able to catch everything. You're not going to be able to see everything. It's just a fact. I mean, you'd have to have an infinite amount of servers and money and time and space and analysts to be able to see every single thing that happens. So as far as someone utilizing unmanaged PowerShell to essentially run Who Am I, it's not the end of the world if that goes undetected. If that's the only thing that someone does when they get onto your machine is run Who Am I, it's all right. There'll be follow-on actions for you to find. And one of those follow-on actions, excuse me, could be creating a new local user. So for this, we actually step out of the sysmon log for, I think, maybe one of the only times we use the security log over the sysmon log. But if you go into the security log, event code 4720, which is new user creation or user creation, I guess new user creation is a little redundant. You can see that a new user was created, site admin, unicorn. There's also some other interesting fields in here that you could take a look at. Source name, that's not interesting. Task category, user management, workstations, not set. One thing that is interesting is the profile path isn't set. So to me, I worked at help desk for a while, like probably a lot of us did, before we switched over to cyber or detections or information assurance, whatever you want to call it, based off of the year that you switched over. But you know that you're not going to make a user account and not have a display name. You're not going to make a user account and not have a home directory or a home drive or things like that. Those are all made all at once. So kind of keying on to those, like things that seem a little bit off, relying on your experience, is something that is infinitely valuable. But you see here, event code 4720 security log sees that unicorn domain machine or account name site admin was created. So we are able to see that. You can't see the actual command of new local user being run, like we said, because it's made an unmanaged PowerShell, but we are able to see the effects, the state change. And then the other one I wanted to go over is the mark of the web, right? I went too far. Ingress tool transfer. So we have in here the first one. This goes over kind of those keyword searches, the invoke web request, IWR, wget, which those will pull up some of them, but if they utilize a different method or encoded or unmanaged PowerShell, et cetera, utilizing the mark of the web, we're able to see here 1,100 a unique event. So again, this is going to require some tuning for you to go in and check it out. I would recommend you could change the target file name to exclude like program files or like system32, like things that you see all the time that you trust, that your risk appetite says that this is probably okay. I'm not going to trigger an alert off of this. Or you could look at it in an inverse way, and instead of target file name, we could do content equals drive. So like the Google Drive, put some asterisks around it and hit search. And so now we're down to only 4 statistics. We're able to see things that were downloaded from Google Drive, from G Drive on there. So again, if in your hunting, in your analysis, you're able to pinpoint some indicators to kind of give you a foothold or a way forward, looking at the contents of it for that host URL or referrer or something like that is very, very valuable. And I hope you guys think that as well. So are there
Hey, Tyler,
any?
actually dropped a cool Sigma role in there in chat.
Ooh. Oh, the system automation DLL, that is a great one.
Yep.
The only issue is I don't have that configured in our sysmon config. It's a good one to look at that DLL hooking for any utilization of that that system DLL management. We just don't have it configured in our sysmon to pull that. But if you do, or your EDR does, that is another great way to go ahead and detect that. Thanks a lot for that. So, are there any other?
Comes down to config and management, people.
Yeah, I say sysmon is great, but like hear Bryson say it all the time, our CEO, it's like free comes with a price, and that price is your time and your configuration. So that part we just didn't get to in the lab. Are there any other ones? Anybody that they found particularly interesting, or any other ways that they found to detect it, or any questions or anything like that?
Was everyone able to follow along with the steps and see results from what we were showing in those first couple sections?
All right.
Cool.
Nothing heard? Go ahead and
keep moving on.
keep
All right,
moving
so
on.
this next group gets a little more interesting. So remote system discovery, PowerShell itself gives us a huge tool set for doing any kind of remote system discovery, whether that's like directly looking locally, so through things like ARP tables, looking at mounted shares, doing traffic capture. There's built-in commandlets for all of that now. And the other little interesting one, locally on host without ever actually having to really do anything or reach out in the network, would be looking at the etc host file. A lot of people don't realize that that's an actual thing on Windows host as well, and it's been there for a while. So yes, there is an etc host in your Windows host as well. But remotely, so thinking about things like just doing TCP scans, ping scans, those kind of things, DNS enumeration for the local environment, doing AD queries, utilizing WMI. So getting back to some of these previous behaviors we've shown, like WMI or using obfuscated PowerShell commands, all of these different kinds of things can be utilized within PowerShell for remote system discovery. So this is one of those where you've got a grab bag full of different ways to try and perform these behaviors through PowerShell. And again, these are just a couple examples of what they could be. There's plenty more.
For sure. So yeah, this detection method in particular is designed just to kind of catch the whole myriad of common discovery techniques via command line arguments. So we put in the command line arguments a bunch of common remote discovery techniques. See, we have that /host there at the end of it. Get win event, get neighbor, and just like net commands, task lists, things like that. We call this just kind of like the all-encompassing LOLBAS, living off the land, binary and scripts, discovery detection via command line arguments. Reason I like to do command line arguments for this one versus like network logs or something like that is if you are querying a remote system that is in your network, in your subnet, oftentimes there won't be anything in between that computer and the other computer, right? There's no switch, there's no firewall, there's no proxy logs, anything like that. So a lot of that stuff would go undetected. So you really have to rely on that process being created and able to find that. But I think in the manual we do have it look at like failed logon attempts, but we'll see if that comes up with anything. But in this one, this is not an exhaustive list of the discovery techniques. There are so many ways. Like we said, there's always another way to do it. So feel free to add more to this as you see fit. The only issue is with the more you add, the more results you get back, the more false positives you get. So this could be kind of a tricky one. But another way you could change the output of this to kind of have a little more fidelity in it is to show that parent image instead of, excuse me, sorry everybody, show that parent image instead of just showing the image. We know the image is going to be PowerShell or CMD, right? But if the parent image is PowerShell abuse.exe, or the parent image exists outside of, again, your program files, or it exists in temp or downloads or something like that, it should kind of trigger you off to that something is a little anomalous, something is a little off, right?
So data compression and archival, we know this is something that people are really kind of afraid of, right? Kind of a ransomware 101 thing. This is part of their whole MO. Yes, they have all of their crazy cool worms and tools and ways that they can go about encrypting your files, compressing them, and shuffling them out of your network. But they also have, and we've seen in reporting, some very simple ways of utilizing the built-in compress archive commandlet through PowerShell, or calling on some of the .NET classes that are available to it to do these kind of things. There's also a lot of people use 7-zip. You've got it installed. We mostly use the GUI, but a lot of people don't realize that it has a backend CLI console that you can utilize as well. All of these are just 3 different ways that they could execute and do these kind of behaviors or actions. And it's rather trivial for them to do it and access it. So these are things you would think about. You're not always looking for some crazy payload. You might just be looking for someone wrapping up a ton of files or directories in weird places, or just using weird extensions or trying to do things you wouldn't typically see a user do. Now, I get some users, they deal with a lot of files on a daily basis. Maybe they're a dev, maybe they're packaging things. So it might be common for some users, but it's not for all users. So that's really where your instincts and your knowledge of the environment and of your user base to understand what could potentially be a false positive as opposed to the real deal.
I feel like I could just skip over my part there, Trey. I feel like you took some of my thunder there. I'm just kidding. But yeah, those are great points. Ransomware is something that we hear customers are concerned with, right? It's a real concern, happens all the time, happens hospitals, banks. I mean, you see it every day, every week, at least, that some kind of ransomware is happening. And a lot of that, one of the telltale signs is compression. So if you can catch the compression and archival before the deletion of everything, so they're going to archive everything and send it off before they encrypt it, or before they delete everything, if they're doing like a double ransomware extortion tactic, you may be able to catch it before the full campaign executes. But for this detection method, we have that it's designed to alert on any file compression or archival not spawned from explorer.exe. So here we see that the PowerShell commandlet compress tech archive was used to create an archive called exfil.zip. And the reason that we exclude or don't include, I guess that's the same thing. The reason that we don't include the image of explorer.exe or the command line arguments of explorer.exe is because that should be how most end users create zipped files, right? Most people, when they create a zip file, they're not going into the command line to do it, because why would you? Most of them just go in to the file, right click it, click, compress file or send to archive, whatever it is. And that's all done through Explorer. So that would be like a pretty typical common way that you would see people archive files if that's something that happens regularly in your environment. Other than that, the only time that I would see, or that I would think of people doing it the command line way, is either an Uber nerd or some kind of administrator or administrative script or maintenance script or something like that, that's going to go in, maybe zip up some files to back up or to clear some space or something like that. And that should be a much smaller set of data. You should get you should get fewer results returned from that, and you can easily exclude administrators or that script from your detection to really bring this down to only not false positives, but true positives. Yeah, and then we have a few other techniques in there. Trey had alluded to a lot of files with weird extensions and a lot of files being created at once in one directory. So those are included in the manual that we'll get into here in a few minutes. But on to the next one. Trey is on mute. Got him.
Say, of course, Sam. Had happened once today. So scheduled tasks, this is a great persistence and potential execution mechanism that we still see used all of the time. And it's really interesting that there's some behaviors in here that I feel don't realize scheduled tasks will do. And a lot of that coming from like potential elevation, but more centered around the way the tasks are triggered. So we all know they can do the normal like specific system kind of event, the day, week, month, time of day, schedules, add a system reboot or a user login. The ones that I thought were kind of interesting and that were newer to me that popped up here recently, I actually again found these through watching my Twitter feed, was the idle state or a session state change for a scheduled task. So like if the machine goes idle, kick off something. If a state changes, kick off the event. So you could potentially, as a threat, build in, set up a scheduled task that executes a payload or does a certain thing when the machine goes idle. And the point here being is potentially now that user's not at their desk, they're not watching the screen, there's not something happening. So if your task might cause a hiccup or might cause like a temporary pop-up or something like that, it might go unnoticed and allow you to persist and move on a little longer. So I thought that was interesting in why we're highlighting the scheduled tasks here. It's another one of those tried and true methods that we're still seeing happen today.
For sure, and that idle state one is very, very interesting. That's a very sneaky way for them to get around seeing, like in our lab, we download any desk and execute that. So if you just have that set to when you're on standby or when the screen goes blank or something, it's a neat way to get around it. All right, but for the detection on this one, oh, sorry, Trey, go ahead.
No, I was going to say, yeah, that's a great example. So like say the download and execution of a portable app or something like AnyDesk, have it happen at the end of the day, user goes idle. Now you've potentially got 8 to 12 hours of unrestricted time to do what you need to do before someone's back at that screen.
For sure. So in this detection method, this is again more focused on state-based. So we're not looking for the command line arguments of SCH tasks or at or however you make a scheduled new tech scheduled task in PowerShell. We're looking for a file being created inside of these tasks directories. So these tasks directories that we have listed under the target file name is where your task and its contents get written to. So even if they do it in unmanaged PowerShell or they do it sneaky and you don't catch it, you don't have logging for that, their task is not going to execute if it doesn't exist here. So I like this one. It's sorry, lost track of my notes. So in this one again, we're not relying on those command line arguments. We're relying for that file to be created. And in this example, we see that C2 check-in was created. What you could do if tasks being created or scheduled tasks being created is uncommon in your network, you could just set up an alert to run this every 24 hours, compare it to the previous days, and if a new one is hit, then you know that a new task was created and you could start an investigation, right? I think that scheduled tasks being created should be fairly uncommon in most environments, or if it's not, it should be easily excludable with just like a couple of directories, right? All right, so that takes us back into our lab time where we'll hunt for the topics we went over, remote system discovery, data compression and archival, and scheduled tasks. So we'll go ahead and we'll do 15 minutes again, and then check on how everyone's doing. If there's any issues or comments or anything you want to throw in, feel free to throw it in the chat, and see you guys in 15 minutes. All right, Trey had pointed out that we are running a little shorter on time than we thought we were going to, so we'll do about 1 or 2 more minutes, and I'll go over 1 or 2 of the detections that we think are interesting, and then we'll move on so everybody has time to get through all of the material. Oh, Donna, if you're trying to change the screen resolution, the easiest way is to just be on the desktop here and right click, go to display settings, and then scroll down to resolution and then just set it to 1280 by 800. Why VLP doesn't, I don't know. We are moving off of VLP soon, so hopefully this will not be an issue in the future. No problem. Okay. And then with that, again, feel free to continue with the manual and the searches and everything. The only real one in here that I wanted to go over, this is my favorite one that definitely gets, I think, a lot of wins for us, is just looking at what command line arguments PowerShell is spawning, right? You could also change this to be what parent process is spawning PowerShell. That also gives a lot of insight. But in here, this is basically, again, this is a lab environment. There's no other noise that's going on. So it's very easy to see exactly what's happening, but it's basically like a cheat code, right? You can look in here and look at the command line arguments and see what it's doing, and see it here that it's getting content of Etsy host we talked about earlier, that it's querying the event log for event ID 4624, which is a pretty novel technique that's utilized by Vault Typhoon to identify good users, known good users, is they just query the event log. Because who looks at the event log? Nobody. You just care if the events are there or not, or if they get deleted, you care. But so this one I like a lot. And like I said, it's you can tune it. You know, we have a lot of Splunk logs that come from this. We just exclude Splunk as the image in there. Really like this one. A really easy win to go through. Just needs a little bit of tuning, right? And then one of the other ones, we did not talk about this in the slides. We just thought that it was interesting. Trey found this this clipboard content. So it's very, very simple for an adversary to run this. It's just get tech clipboard, and it'll pull back what is on the clipboard. So if you have like an administrator who's copying password, I mean, you keep all kinds of stuff in your clipboard. The initial one that Trey found, which if you still have it, you could throw it in the chat. I think people might find it interesting. Basically just checks, it's like while true, it waits a second and then looks at what you have in the clipboard and returns it to you. So that is a really interesting way for adversaries to just continually get your clipboard and see stuff that's in there. You know, you could output that to a file and just grep for password or do some regex for passwords or something like that. We didn't include it in here because we thought that this one would get the point, well enough across, and with some of the loops in the platform, you have to background it and all that other stuff. So, but very, very interesting. I thought that it's an honorable mention of sorts. But with that, I think we'll get back to the slides. We can make sure we get all the way through them. Sorry about that. All right. Trey?
Yeah, I'm not on mute. Cool. Credential dumping. As you can see up here, we've got the good old trusty Mimikatz as an example here, but utilizing PowerShell, there's so many different ways that we could utilize it to dump memory, or not dump, dump credentials that are either like stored in memory, maybe they're on disk in a specific file or a hive. The example here is just doing the whole SecRSL logon password, so looking at LSA. And you have so many other options too, so like using PowerShell to call maybe another executable like run DLL or comm services. Mini dump, you could use PowerShell to enumerate things like the command key to see if there's anything stored in there. Doing things like dumping the SAM or system hives out of registry. Process captures, so you can take the dump files back and copy them. And it's all super simple and easy to execute. And it's something that we're still seeing, like these routes are being used today. And honestly, to me, it's still surprising with how signature it is that things like Mimikatz still fly under the radar for some threats.
Yeah, I feel like the only time it's ever caught is when people try to download it from the Atomic Red Team GitHub link, and the GitHub link is just blocked. It's not the actual activity itself. But we have for a detection for that, like Trey said, it can be difficult to identify credential dumping because it exists only in memory. So very similar to the upshell that we were talking about earlier, detecting things in memory can be much more difficult. It's when you want to look at that DLL hooking and things like that rule. I don't remember who posted it, but like that rule a little bit up to look for the system automation DLL. You can make configurations for DLL hooking and things like that, but a very easy way that I had seen is you want to look at what images are trying to access LSAS. So LSAS is, for those who don't know, is essentially what your logon service is that verifies and stores hashed credentials. So when you log on, it interacts with LSAS, you're in there, and then your credentials are stored there. So adversaries will typically want to dump your LSAS process to get those hash stored credentials and either crack them offline or do a hash the pass pass the hash. You don't want to hash the pass. That's crazy talk. To pass the hash to allow them to laterally move or have your credentials or what have you. So in this, we see that that PowerShell.exe is trying to access LSAS.exe. Should be an immediate flag. This should be the highest priority thing that you work on that day. Should it be immediately looked at? Anything that is accessing LSAS that is abnormal or uncommon or anomalous should be investigated with haste. I'll leave it at that.
So defense evasion, this could almost be a workshop itself with how many different things we have the potential of doing here. Just for this example, we went with something that would still get the point across and be visible in Splunk and usable for a workshop. We took this route and just doing a simple adding exclusions for file extensions to Defender and real-time protection. This was kind of a cool little way of doing it, but there's so many other potential options we have here. So like setting the exclusions for not just like extensions, but for file paths or specific files, disabling services as a whole. One of the more interesting ways I've seen it done is for a lot of these, like say cloud services or other defensive tooling that are put in place is just black holing the DNS. So setting rules in place, whether that's through firewall or through the DNS configs, things like that, saying just don't let this traffic out. So it can never really do like a real-time check and reach out to its cloud services. So that's kind of a cool way of going about it. But I mean, there's other things as well, like doing simple registry key modifications. I mean, you could do stuff similar as well for proxy execution or process injection. You should see an example of one of those here in a little bit.
Yes, that takes us over to the detection for this. So for this, we're looking for that Mav inject that's running. So that is a native tool on your Windows machine that I don't know what it does legitimately, but it's utilized to inject processes or DLLs into processes. So our detection rule here is more command line based. So it looks for that / inject running and not a parent image of that app feed client, which is a legitimate use of the Mav inject image. So when here we see that Mav inject is injecting the PowerShell abuse.dll into calc, which if you guys notice, once you deployed the threat, after a little bit, that calc popped up for seemingly no reason. It was so we could inject the DLL into it, which should have opened Notepad or something like that. But one of the ways you could go ahead and detect it.
So yeah, Mav inject is one of those things that's built in natively because of AppV and the virtualization platforms on Windows.
Oh, I think the slides might have gotten out of. Oh, I think we just had a duplicate of it. So this is more into the process injection. So getting into the the Mav inject that we just talked about. I think we just had kind of a duplicate.
Yep. So now you're stealing my thunder.
I know, a little switch.
So on process injection, real quick, that example. So we're using Mav inject to basically input our payload, or in this case, the PowerShell abuse DLL, into calculator. This could be realistically anything you want it to be. You could do, there's precursor commands you would expect to see. So like looking for active running processes beforehand. It'll identify a specific process, maybe it's got a permission set they want or a capability. Insert that in this, and then just inject their payload into that to get their execution. Tyler already kind of talked through that detection there.
Yeah, so we can go ahead and move through. Yeah, Trey, sorry, I don't mean to keep cutting you off.
No, you're good. Remote services. This one is, there's a lot here. There's so many different ways to crack this particular egg. The utilization of things like RDP, PSExec, WinRM, SSH. A lot of people don't realize that OpenSSH is built into Windows 10 and above now by default, as of one of their honestly, it was one of their updates last year, 2022. So you have the ability to do things like generate SSH keys, move around the environment, or just take advantage of the service already being on and open. I know a lot of administrators like to use SSH or SFTP to do stuff nowadays. So these services are all, they're kind of built in, they're there, and why not take advantage of them, right? Thanks, Priscilla. Have a good day. Hope you enjoyed it. In the example we've shown here, it's just doing quick little like password spray, utilizing SSH as the medium to validate whether or not the credentials are right.
Yeah, so in this one, again, we're just kind of relying for this detection method, just relying on those command line arguments for SSH, PS session, PS exec. If either the command line or the image is that, we want it to show up. You can even see on the second line here in the output that SSH keygen. So there's a little happy accident. We also do that in the threat later on. So this detection, just from, this is, one of the times where keyword searching sometimes is really good, where it can pull other instances of malicious activity just by looking for those keywords that way. I believe we also have for this one as an included one for failed logon, which is event code or failed or successful logon, which is event code 4624 for successful and 4625 for failed. So if you see a bunch of failed, logon attempts and then one successful logon attempt, it could key you into something like brute force or something like that. But that's in the manual. I just thought it would be worth talking about.
And so our last one here, impact, this is ransomware 101, right? You could take any or all of these specific behaviors and more, wrap it all together and cause some form of, say, data encryption, IP theft, execution, destruction, anything and everything you can really think of would fall under this banner. So it was kind of hard to come up with a very specific screenshot example to give you for this one. But we still see PowerShell using these things all the time. It's not hard to delete directories, to remove directories, to say, change permissions, file types, encrypt things, generate yourself new SSH keys, lock out users from RDP, do anything and everything you can think of is potentially possible here. So it's kind of our grab all.
Yeah, so there's so many different impacts. I mean, it was such a long list, but again, like the ransomware is just on everybody's mind. So that is the one that we kind of keyed in for this. So in this one, we have our we're looking at event code 11, which is file creation in Sysmon. And then just for target file names, we just put a few of the common ransomware file extensions in there. For this one, I mean, there's a huge list, new ransomware every day. They could change the file extension, on a whim, as far as like where the pyramid of pain would be for changing the file extension probably wouldn't be too difficult. We have another detection, we have another detection in the manual where it looks for, I believe it's 20 or more files being created in less than 5 seconds. So that'll give you a lot more fidelity on identifying ransomware. I had a conversation a few weeks ago with with a client about how to identify ransomware, and I was like, brother, you don't have to identify it. It'll let you know. It'll pop up when you go to log in. But maybe you could utilize some of these to catch them on systems before they spread across your environment, right? Before that worm effect of the ransomware takes place and it gets on your shared drive or your DC and spreads and populates across your network. But that is in the manual, which
And this
we are
is
now
one
in.
that's been a little interesting too there, Tyler, is that we've noticing that a lot of people, security vendors, are kind of catching on to this thought process and realizing that like these steps have to happen for ransomware to happen. So you'll start seeing some of the more prevalent EDRs and things starting to flag on mass file creation or file changes within a certain time period and stuff, and popping alerts that way now. So they are trying to get rid of some of this stuff and put it in place to give you alerts ahead of time, so you're not just stuck trying to triage ransomware after the fact.
For sure. So that takes us into the lab time, which will basically take you to the end up until the bonus part. So you guys can go ahead and get started on that. We'll do, the 10 or 15 minutes like before, then go over some of the key ones, and then we'll wrap up. So as you're doing the lab, another point that you had alluded to, Trey, is that that time-based detection, putting in a little bit more logic into it. So Sigma was not able to do that before, but recently, as in I think last night, they just announced an update where they're going to include like correlation logic and time logic and like counts and things like that into their rule sets, which is awesome because it'll allow for to write some better detections with a little more fidelity, a little more logic when I give rules to or detections to clients or customers. As far as like time-based ones are set, I have to just send them the Splunk query now, or tell them like, hey, whatever your EDR is, set the thresholds like this. So now that it's going to be included in Sigma, that's going to be a really good jump for detections in this kind of like correlation-based, time-based events. But yeah, so go ahead and do this live. We'll take us through the bonus. We'll do 15 minutes, hit one or two. Like I said, and we'll wrap up, and I think we'll be right on time.
So just as an admin note for you guys, this workshop and the Zoom call will end off at 4 p.m. Eastern time, but we went ahead and extended your time in the lab by another hour. So after the Zoom call cuts off, you've got another hour or so afterwards to go in and play and mess around with Scythe and some of these detections and Splunk and all of that fun stuff. So feel free to play around with it afterwards.
Yeah, for sure. If you have some PowerShell abuse techniques that you want to deploy on the environment, or you want to deploy another threat or something like that, go ahead and go deploy detection crazy and be like your own little purple team, all in one.
So Spyros, if you wanted to mess around with Star Killer in the environment, there should be a a bookmark in Chrome to go ahead and let you hop in there and mess with it. There's a few different things in there. In our previous Power to the Purple workshops and threat emulation workshops, we use Empire and Starkiller to show alternate methods of performing specific actions or behaviors, or just running emulation campaigns in general. We actually have a workshop coming up. I believe it is next month, where the awesome guys over at BC Second Us are going to kind of tag team doing a workshop on using Empire and Starkiller for threat emulation. So that'll be cool.
I'm on mute. Look at that. You can also use the shell that's built into the Scythe platform. If you just go to the campaign where it has the request and response in the top right corner, there should be a shell. So if you want to deploy anything, any PowerShell commands or anything like that, the easiest way to do it is just to do like run space PowerShell space -C and then whatever PowerShell commands you want to run, and they'll show up. Or deploy, not show up. give it about 2 more minutes. I'm trying to get this one search to show up. And then we'll go over some of the things in here and then wrap up the slides. You guys will be on the bonus the bonus searches and questions and stuff, and we'll be free to play around. About 2 more minutes. Trey, you're on mute if you're talking.
That is good because I was talking to myself. Yeah, I was gonna say, while you guys are playing with those detections and queries, I just wanted to show something off here for a minute. I know this workshop is hosted by Scythe, but we didn't really focus too much on the platform today. So just wanted to take a second so you guys could see kind of the effects of what you had ran earlier. From the main Scythe campaign dashboard, you can see the campaigns we've run down here. If you click on the host that you executed it against, it'll show you all of the steps, the request and the response that were sent and ran. So like, for example, that first PowerShell encoded command, we can see it come back. That's what we sent to the implant. This is the return. And you can step through this. You can see all of your steps, if they succeeded or failed, the timestamps and any potential tags that got applied to them. So this is just kind of an interesting, different little view for you to see how all of these emulation steps were executed and what actually went on. So if you wanted to kind of correlate what you're seeing in the detections versus what the actual threat campaign did, you have that ability to.
Pulled a Trey on mute. Man, like the 3rd time it's got me today. Nothing super crazy in this one. We went over a lot of the detections for it already, kind of in the slides, where they're based off of command line arguments or images, things like that. It's nothing super crazy to show. There was this ransomware, the encrypt files down at the bottom. So for file staging, so 20 files created in 5 or less seconds. I don't know if there's an issue with how it's copying over or what. So I pulled up our Splunk instance that we have in our lab and ran it, and you could see in here. So it's basically going in event code 11, which is file creation, not images in Clean Manager or MSMP ENG, which is Windows Defender. It makes a ton of files, or Splunk, which again makes tons of files. It looks in the target file name and pulls out the directory. So it's looking in that directory with some more logic that's based on it. If anything in that directory that creates 20 files in less than 5 seconds, or this is 2 seconds, not 5 seconds, 20 files, 2 seconds, give me the target directory and the image that created those files. And you can see here, it requires a bit of tuning still. It's all based off of your environment and things like that. But you can see here at the bottom, we have ransomware.exe and the PowerShell abuse.exe, which is what we named the executables when we were doing testing and stuff, had created 25 and 24 files inside of this PowerShell abuse. So that could be indicative of ransomware. This will alert when all of those file names get changed, or if they're all archived into one spot. It really will just show any kind of data collection in one spot in an automated fashion. So I'm not sure what happened in the lab, if maybe a config got messed up or something, but that's what it should look like. So that one is very, very useful. And then also not the bonus fun, but we were looking at for disabling antivirus and EDR and trying to find a way to show that in Sysmon. We're having some issues other than just like command line arguments or things like that, which again is not really how we want to show it. We want to show it in that state-based where you look for things that can't be bypassed, right? So the one that Trey found is this event ID 5001, which is particular to just the Windows Defender event log. So kind of an atypical place to look at logs, at least for me. I've never ingested these logs or even really looked at them before last week or 2 weeks ago whenever we were making this part of the lab. But it's inside. If you open up Event Viewer and go to App and Service Logs, Microsoft, Windows, Windows Defender, and filter by event code 5001, which is malware protection RTP, which is real-time protection. For disabled, when you click on that, it's a little blurry. Sorry for the screenshot being a little blurry. But you can see in there 5001, and that right there, Windows Defender antivirus real-time protection scanning for malware and other unwanted potential software was disabled. So definitely one to monitor and to be abreast of that happening. When you ingest logs in your SIEM, you don't have to take the whole log. You can filter it down even more. So I'm going to update our lab to ingest that log. I think it's very, very interesting, and note any changes that occur, any unauthorized changes that occur, because you really shouldn't see your Defender or antivirus or things like that being disabled, right? That should be some immediate alarms.
Yeah, this one was a little weird too, because you had two potential options to search on it. One, I think, was like event code 1015. And all that is basically like a Defender health check that runs every hour, and it tells you the status of all of the other Microsoft Defender or Defender for Endpoint services. So like ATP, real-time detection, all of the other little things. It just tells you if it's on and healthy or if it's disabled. That one makes a lot more noise, especially if you ran it across your enterprise, but I know it's a little easier to find. This one here, this event ID 5001, the only time this is going to pop is if someone actively disables it. So
yeah,
it's a really good indicator right off the top.
Yeah, for sure. So yeah, we wanted to just point that out. So we don't have it adjusted in the lab. Just thought it was very interesting and could be useful. Mr. Valencia, goodbye. See you this weekend. Okay, and then that takes us up until the bonus fun. But we'll go ahead and wrap up the slides and leave you guys to the bonus fun kind of on your own. Trey, you're on mute.
Had to, end of the day. So obviously, Seth, we've got some awesome swag. I know you guys have seen our unicorn popping up everywhere. If you're the kind of person that likes t-shirts, sweaters, koozies, hats, all that kind of fun stuff, you can find them at that link down there, swag.scythe.io. And this is one of those things we just kind of do for good. We're not making proceeds off of it. Anything that comes through that swag shop is donated to a conservation project helping to save our chubby unicorns. So go check those out if you would like some awesome swag. And there's a little example here of one of the koozies that I tend to use all the time that we've got up there in the swag store. It's
hoodie,
awesome.
Shirt, lots of swag.
Yep. And with that, that is the end of our presentation for the day. We got about 8 minutes left live, and then you guys have another hour again on the lab time. Was there anything interesting that's popped up, or any thoughts, questions, concerns you guys had over the workshop? Hopefully everybody got something new out of this one today or took something home from it. If you do have interest in attending our other ones or any of our upcoming workshops, you can find them here.
And then it seemed like there was some a lot of interest in the manual or the rules. So Trey and I are gonna go ahead and package that up nicely and send it out to everybody that gave email addresses or expressed any interest in it. So you have that. Look for that here in a few days, probably by the end of the week for sure. And then as far as the bonus stuff is concerned, again, all of those threat steps are already ran. So you could always, I don't want to say cheat, you could always take a little peek at the threat if you need a little extra hints and kind of see what was going on. We have the threats organized. We have these not variables, they're variables, I guess, that have the technique and then what it's doing underneath it. So if you go down to the bonus here, you can see some of the stuff underneath it. Like I'll give a little sneak preview. Inside of our virtual file system is where this anti-av underscore stop.ps1 script, that was really hard to say, is located. So you could go in there and pull that script down and check it out, see what it's doing. We have just like some hints and some questions over here, just kind of help you along. Yeah, enjoy the bonus. Hopefully everybody had enjoyed or at least taken a bit of the course, and look forward to seeing you guys hopefully in the future.
I will say for this one and the bonus ones, the question number 4, the behavior that happens there is really interesting. That's gotten me a few good wins on some pen test and red team engagements before.
Yeah, and then yeah, if you guys have any, we'll stay on for a little bit, but we're always reachable at proserve@site.io if you have any questions, or you hit us up on Twitter or anything. We're accessible. Yeah, thanks a lot, everybody, and again, hope to see you on the next one.
So Jeffrey asked your question in Q&A. That's really a varied answer. It depends on what you define as precise and what you're trying to detect. Some stuff is super easy to find. Other things is going to take a lot of tuning to push out white noise.
I would say for that, I mean, I've been been doing detections and threat hunting and things like that for a little over 10 years now, and I've deployed to a lot of like customer networks to kind of come in to assist in incident response and things like that. And the part that takes the longest isn't necessarily crafting the detection, but it's working out all of that noise, knowing like getting a baseline and filtering out. Every network is so different. I must have been on 3 dozen networks in the last 10 years. And it's like it just takes a lot of time to go in and filter out what's good for their environment. What admins are doing, what different software they're running, and things like that. But if you're on your environment, I'd say before you can really even get to precise detections, you have to get a baseline. You have to know what's normal, what's abnormal, and then filter it out from there. We didn't talk about it too much in this as far as like how to go through threat hunting. We do that more in our detection engineering course that Trey and I put on. But you want to start with that wide net. You don't want to miss anything when you initially go ahead and do it, and then slowly bring that net in, make a smaller net to hit on mostly the true positives with limited false positives. But that is really not possible without knowing what your environment is.
People really discount having an actual asset and software inventory, understanding user behaviors and their environments. That goes such a long way to finding bad. It's a necessity. If you don't have it, where do you really start? Everything is bad at that point.
Yes, everything is bad. There was some other Twitter post I saw a while ago that was like every administrator script looks like an adversary doing something. It's 1,000 lines, it's encoded, it's got variables, it does all kinds of stuff, it's reaching out. That person, we have been on missions, on engagements where the admin had been gone for years, but their script was a startup script that ran on every machine. We must have saw 10,000 of them, and we're like, boom, we found him. We found the bad guy. We win. High fives all around. And it's just like it's
Steve from 5 years ago.
It's just Steve that has been on there forever. No one noticed or no one cared. No one cleaned it up. So yeah, it's a long-winded way to answer your question, but really getting that baseline, I can't express how important that is to take the time and really know your network and your environment.
Anybody have any other parting questions for us before you guys hop out of here? So we do a lot of these public facing workshops and live streams and things like that. If you haven't checked them out before, we do one called Threat Thursday Live. They typically happen every second or third Thursday of the month, but months like June here, we've done a couple. We did one last week and we've got one coming up again on the 20th. in those, like, we're talking about all kinds of various different things, whether it's new threat emulations we've created, maybe it's a particular way of doing something. Last week, we were talking with Jake Williams, or Malware Jake, if you follow him by handles, about breach and attack simulations and really how it can be improved and what we could do better as a community when thinking about BAS. So feel free to check those out. Let us know what you think, and we're here to support you guys. So if there's other stuff you'd like to see, cool stuff you'd want to see, that's what we're here for.
Yeah, and then Jeffrey, to answer your the other question you have in there, it's still, even like out of the box, you still have to, at least in my experience, you still have to manually filter out all of that noise. I haven't found a tool. They say that they say machine learning or heuristics or things like that, and frankly, I've never been impressed with any of that. I think that a lot of that is chalked up to buzzwords and things like that. It always takes someone to go in there and go through the noise and identify things that are known good, or at least as far as your risk. I use the term known good. It's really like what your risk appetite sees as being good, or sees as being known or benign or false positives, etc. But at least in my experience, it's always been down to an analyst or a human person to go in and filter that noise out.
We went on one engagement a little while back where we noticed that the customer was purely just hunting from their tooling. They didn't aggregate it anywhere. And their EDR was kind of wonky at times. Like some things it would really alert and highlight, or sometimes it would just block and never give you any kind of alert to let you know it did anything. Or it would just say, "Hey, that's kind of suspicious," and then let it happen anyway. So they're very handy and helpful tools, but they're not really end all be alls. You have to have checks and balances in place, right?
Yeah. With that, we see, that people will buy something and think that just throwing money at the problem is going to fix it, and it just doesn't. There's no tool. I don't want to sound soapboxy, but there's no tool that's going to replace just getting in and doing it. Unfortunately, it's always going to take some kind of human interaction, some kind of risk-based decision to what you're going to filter out and what you're going to be doing. So, thank you for that. That was a really great question. Very thought-provoking question. I've never heard of logarithm coding. There, Scott. I don't know what that is, to be honest.
Yeah, so that is not one we have messed with there.
Yeah, I'll have to check that. I'm adding it to my bookmarks now. Yeah, I've never heard of them.
I would be willing to bet that a lot of like the signal rules and stuff we're using, though, if they're a popular platform, there should be an option to translate it from Sigma into logarithm, whatever it uses as its query language.
Yeah, that again is why we like to do the detections in Sigma. So that way, regardless of what endpoint you have or what EDR, whatever solutions you have, whatever you spent money on, you can translate these rules across all of them with little to no modifications. And so that's why I really like it, why we speak so highly of it, and we have the course on it. I really couldn't say enough good things about it. And yeah, Donnie, you hit it right on. Everything should be automated. Yeah, it's like it just doesn't work like that. I mean, there's some things you can automate and pipeline and speed up and things like that, but a lot of the time it just comes down to someone getting in there and just putting in the hours. It takes a lot of time and it's not easy, but it is fun. I do really like it.
For anonymous attendee, we do not have a public Slack or Discord that we monitor and maintain. That takes people time, manpower, and a lot of community corralling, and we just don't have the ability to maintain another one outside of what we're doing. A lot of us are already doing second or third jobs outside of work where we're helping with like ICS Village or other nonprofits and things like that. So maintaining another one would just be too much at this point in time. But we're always reachable on social media. We're reachable at these workshops. You can find most, if not all of us. So like myself, Tyler, Bryson, we're all going to be at Black Hat and DEF CON. So we're around. Feel free to reach out.
Yeah, and to double hit on the feeling free to reach out. This is something Trey and I are very passionate about. Done it a long time. Absolutely love it. So don't feel, you can reach out to me whenever. I'm always available.
All right, with that, I think I'm going to stop the recording.